My name is Beto, and I've been here at GTP for 2 years already. This year, since last year I started working in coral rehabilitation, so I get more involved into corals, coral reefs, and how to help them a little bit at GTP. And it's kind of cool. Coral reefs from the past few years have been threatened, mostly because of human activities. It's not because there are many animals in the ocean that are killing corals. That's not what is happening. So coral reefs right now are facing two very important global threats, which are global bleaching and ocean acidification. Both of them related with CO2 emissions to the atmosphere and global warming. So global bleaching will be probably the most important threat for coral reefs right now, or even from the past 15-20 years. And what it means is the temperature of the ocean is rising to levels where corals are not ready or are not adapted to resist that changes, and they bleach. Corals are living within the tissues with a tiny plant-like organism, which is responsible for most of the coral growth. It's responsible of 90% of the energy that the coral needs for its own survival. And when the temperature rises, the temperature of the ocean increases, this plant-like organism is going to die, it's going to disappear, the animal, the coral is going to expel it out, and the consequences are the corals bleach. On the other hand, we have ocean acidification, also related with CO2. So the more CO2 that is dissolved in the oceans is causing the pH of the ocean to decrease, to become more acid, and that means corals as well as other organisms that depend on shells, they might not be able to synthesize and to produce their own calcium carbonate structures that they need for their own survival. So that's why many scientists, many projects all around the world in many countries have come with the same idea, which is to rehabilitate, injure or damage reef areas, where what we just basically do is to attach artificially broken coral pieces that can be found all around the reef into other structures to accelerate and to make easier for corals to regrow again. So it's not an artificial reef, it's more to use areas where there used to be corals and now there are no corals anymore, and to increase the number of corals again into what it's supposed to be in normal conditions. And what GTP is doing is consists in creating artificial substrate made with concrete. So we make concrete blocks to provide an extra support onto these rubble areas to make it more stable because they are heavy. And over these concrete blocks is where we are gonna collect first broken coral fragments to later on attach them using different tools, from cable ties to metal wire to marine epoxy, also to try to find out which one is the best for corals. And yeah, so we started working in the middle reef, which is the one that divides the Juara Bay in two beaches. Because we find out more damaged areas than on the others. That's why we started with this one. The idea is to provide artificial substrate, transplant coral fragments, and then the most important part is to maintain them. So these are the structures that we are making. As you can see, we have two types, two different models. So we have one type of block that we are making using glass, with the idea also to reuse the glass that is being produced in Juara, and also because it's a really good material. Glass is made with the same materials as sand is the same structure, so it's gonna remain in the ocean for a long time, but it's not as aggressive or polluted as plastic. And then we have this another type of block, which is just holes under the block. The idea is also to compare which type is more efficient. So here I brought 2 coral fragments. The size that we are using for coral rehabilitation is around our hand, so more or less like this size is a really good size for them to grow. It's not small where they have less chance of survival, less survival rate, or if it's too big it could consider as a proper colony and it's better to leave it on its place. So more or less like our hand, and I'm gonna explain first this type of block. So we come with the fragment and we are gonna attach it to the bottom of the block, like touching the surface, and also to the glass. So we will use a cable tie to tie it to the block, but it's very important to touch the concrete surface because the coral will expand their tissues over the concrete. Some people will attach it to here, which is good as well. The corals will grow, but it will take a lot of time for them to grow over here. They need to grow all the way down of the bottle and then touch the concrete. So if you can directly attach it to the glass, they will grow in height, but also they will colonize much faster than the coral surface. The other type that we are using this year, it's a new experiment, and we believe that it's going to work very well, is making these little holes on the block. So then we fill them with marine epoxy, which is a substance that gets really hot in just a couple of hours, and we are going to stick the coral into it. So the idea, well, it's a little bit tricky because you need to find which one it fits, but the idea is to get the coral fragment stuck on the hole and then apply epoxy around it. So it's going to be really stable once the epoxy gets hot, and it will colonize the concrete surface fast, really fast. And we are trying to guess which one will work faster. But also it's very important to to have the concrete surface rough, not smooth, because corals will grow faster over rough surfaces than over smooth surfaces. So once we fill all the blocks with coral fragments, we will come back to check these structures several times per week. During the first couple of months or 3 months, we will go twice or 3 times a week or 4 times a week, every 2 or 3 days, something like this, to clean with a toothbrush all the surfaces that potentially the coral will grow over, as well as the cable tie or the attachment tool that we use, facilitating the coral growth over these attaching tools. So the more we keep the block clean, the faster the corals will grow. There are less competitors growing over the concrete, so they have an easier way to colonize the substrate. So that's why it's very important to clean them. So that's going to be during the first 2 or 3 months. After that, it will be once or twice a week, and after the first year, we don't clean them anymore. They are mature enough. They have been for 1 year, which is time enough for them to get attached to the substrate, and we don't need to clean them. Normally, they will take around 2 weeks, 1 month to grow over the cable tie, the metal wire, or the epoxy. What we have seen is after 2 weeks' time since we transplanted the fragments, there is already signs of growth on the cable tie, for example, or on the marine epoxy. And it takes 1.5 months for the coral to grow completely over the epoxy or completely over the cable tie. And after 2 or 3 months, we have seen already the coral touching and growing over the concrete block. So in 1 year, they have been experiencing a lot of growth, and they are big enough to don't need any kind of maintenance, basically. So for this program, everyone is welcome, more specifically divers. The requirements are minimum open water for all the activities that require diving. To make concrete blocks, it's not necessary to be a diver, so if anyone without diving license wants to know or learn about coral reefs, coral rehabilitation, are welcome to receive a presentation and to participate in the block making to help us creating more artificial structures. But to all the work that involves diving, such as cleaning the fragments or collecting fragments or planting coral fragments, is required to have minimum open water diving license, as well as 20 dives logged, right?